Swayam Prabha. Digital India. Educated India.
In the previous lecture we started discussing about how to modulate surface tension. So we were discussing about that how to generate gradients of surface tension, maybe by generating gradients of temperature, for example, which is known as thermocapillary or Marangoni convection. Now to generalize, let us say that there is a free surface. For the time being, let us assume that the free surface is flat. In our next chapter we will see that I mean how to modify this if the free surface is itself curved, but for the time being let us assume that there is a flat free surface for simplicity. So let us take a small element dx. Now on this small element let us say here the surface tension coefficient is sigma. Let us say that the width is 1, width equal to 1. So this is sigma, and let us say that here the surface tension coefficient is sigma plus d sigma. Why this is sigma plus d sigma? Because maybe there is a temperature variation along x, because the temperature variation there is a surface tension variation, so sigma has changed from sigma plus d sigma. Now we can write so there is a imbalance of sigma and sigma plus d sigma, so that may be balanced by a shear force which is tau into dx into 1, where 1 is the width. So we can write from the force balance, that is sigma plus tau dx is equal to sigma plus d sigma. That means tau is equal to d sigma dx. So we can write this as d sigma dt into dt dx. So you can see that how a shear stress can be generated because of surface tension gradient, and this stress can be the driving influence for the fluid flow to take place. Okay. So this is one effect that we discussed in the previous lecture, this is just a continuation. Controlling surface tension by surfactants also is a possibility. So surfactants are short forms of surface active agents, are compounds that lower the surface tension between two liquids or between a liquid and a solid. Molecules are attracted by interfaces, so you can create an assembly of molecules which are adhering or attached to the interfaces, and there are several applications of surfactants like in emulsification, in detergents like in soaps, in micelles and so on. So, basically adding surfactants is a way of controlling surface tension by creating a concentration change, by making a change in concentration by adding surface active agents. Controlling surface tension hydrophilization. Now this is a very important point to discuss. In many microfluidic devices, the substrates that we are using are originally hydrophobic, like for example PDMS, we will discuss about this, like polydimethyl siloxane, that it is inherently a hydrophobic substrate. Now these hydrophobic substrates may need to be hydrophilized. So how they can be hydrophilized? There are certain possibilities. So the fundamental principle is attaching polar groups or non-polar surfaces. So commonly what is done, this process is routinely done in our labs, that is we have oxygen plasma treatment or plasma activation. The surface reacts with reactive molecules. So you have gases like oxygen or you can have water, these can be ionized, and so basically you can attach polar groups on surfaces, and these polar groups can impart hydrophilicity to the substrate. That is the fundamental principle. Now this particular principle, I mean it is good to use, it is quite cheap, so in labs it is very convenient to use, but one of the problems is that it is not long lasting. So the hydrophilicity that has been imparted will go away if you leave it for beyond a critical time. So it depends on how long you are doing your experiments. If you are doing experiments over a period of time over which the hydrophilicity remains, then that is fine, but otherwise you have to go for a permanent treatment. So permanent treatment is coating with a hydrophilic material, for example Pitox is a material. So you can make a coating with a hydrophilic material, it is long lasting, it is not a short time solution like oxygen plasma treatment or plasma activation, but it is costly. So I mean this is of course quite obvious that any process which is not long lasting will not be that expensive, but process which is long lasting is expected to be expensive. Controlling surface tension